Hi everyone, this is Donnell from Twig Learning Center. So let's run through some stereoisomerism questions. Okay, let's look at the first question. So this is the structure of morphine. They say, which of the following claims of a morphine is true? There are 5 chiral carbons present in the molecule. So let's take a look. So I believe there's 5 chiral carbon here. So 1, 2, 3, 4, 5. Yeah, so these are the 5 carbon that I just highlighted. So this statement is definitely true. Okay, no more chiral carbon. Okay, there are 7 CC bonds formed by sp3 overlap. Okay, so I'm going to look at all the carbon that are sp3 hybridized. Let's take a look. I'm going to use a highlighter. Okay, so sp3, 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 and sp3, sp3, and sp3. Okay, so all the highlighted ones are sp3 hybridized carbon. So are there 7 CC bonds, the sp3 overlap? So 1, 2, 3, 4, 5, 6, 7. Can you see that? So there are actually 7. So this actually is also true. The molecule cannot exhibit cis-trans isomerism at the CC double bond. Okay, this CC double bond is part of a 6-membered ring. So we know that actually if there's a double bond in a 6-membered ring, cis-trans cannot exist, right? Because the trans isomer is what we call a very strained structure. So if like anything that is, for example, so if like you have a BR and a BR here, this may be cis, but it's very hard to get a trans structure like this. So imagine if I try to draw a trans, it should be something like this: 2 carbon here, 1 carbon here, 1 carbon here, and these 2 carbon are just too far away to join. All right, so they are too far away to join, so trans does not exist. Right, so we know that a double bond within a 6-membered ring wouldn't have cis-trans. Minimally, you must have 8. Okay, 8-membered ring with a double bond inside, then you can actually have cis-trans. Okay, so this statement is actually correct. So answer is D. Okay, let's look at the second question. Golexonolone is a drug currently being studied for treatment of hypersomnia. All right, so let's see the total number of stereoisomers. So we're going to look out for stereoisomers, right? So stereoisomers refers to either cis-trans or enantiomerism, right? Cis-trans isomerism or enantiomerism. So we're looking for chiral center. Okay, I'm going to circle all the chiral center here. Chiral 1, 2, 3, 4, 5, 6, 7. Okay, there is no double bond. Oh, there's actually a double bond over here. This N has a double bond. So this is kind of tricky because actually this N has a lone pair. And in fact, this N actually with a double bond also has cis-trans, because you could actually draw the other structure like that. They drew a double bond N, and you can draw the OH on the other side and the lone pair over here. So actually, and they are not the same because due to restricted rotation about double bond, so these 2 structures actually are not the same. So I'll consider this part as having also cis-trans, right? This part would also have cis-trans. So let's see how many are there. 1, 2, 3, 4, 5, 6, 7, plus 1 more, 8. So it's actually 2 to the power of 8, right? So that gives you an answer of B, right? So this is a total number of stereoisomers exhibited by this molecule. Okay, let's look at question 3. Which molecule are optically active? Okay, so when it's optically active, it does not have a plane of symmetry. Okay, when it's optically active, it does not have a plane of symmetry. So this first molecule does actually have a plane of symmetry. Okay, it's cutting through here because the BR is on the same side and the CH3 and CH3 are also on the same side. You can actually cut across, right? And it does have a plane of symmetry. Okay, this molecule for 2, question 2, it doesn't have a plane of symmetry. Why? Because the BR here is actually behind the plane, and this BR here is in front of the plane, so it wouldn't have a plane of symmetry. You cannot say that this is a plane of symmetry. It's not. All right. So I'll just remove it. There's no plane of symmetry. Okay. So this molecule will be optically active. Okay. In this molecule, is there a plane of symmetry? In fact, there isn't a plane of symmetry because you can't say that this is a plane of symmetry. The same concept, because this BR is sticking out of the plane and this one is into the plane. So that is not a plane of symmetry. All right. So yeah, so this molecule will also be optically active. So the answer is 2 and 3. Okay, let's look at question 4. How many stereoisomers does this compound Q exhibit? So again, stereoisomerism, so we're looking for cis trans as well as chiral center. So 1 chiral center, 2 chiral center, 3 chiral center, 4 chiral center, and this part would have cis trans. So it's going to be 2 to the power of 5, right? So 2 to the power of 5 will give you a value of 32. So the answer is D. Okay, let's look at the next question. Which hydrocarbon, when reacted with chlorine in the presence of sunlight, will form a monochlorinated product which both shows cis-trans isomerism? So for this question, the answer should be D, right? Just to give you an idea why it should be D. Because if it forms a monochlorinated product and it would also have a chiral center, so this is where the hydrogen will be substituted. So you've got to substitute this hydrogen. Okay, so this is what it should look like. So the C, there will be a H over here. There will be a CH3. And one of the H should be substituted with Cl. Okay, so this is a chiral carbon. So there's a chiral carbon here, and over here there will be cis trans. Right? If you try the rest, you probably have cis trans, but you won't get a chiral center. Okay, so you can give the rest a try. Okay, let's look at question 6. Which compound exhibits both cis trans and enantiomerism? So again, it must have cis trans, means a double bond, whereby these two groups must be different, and these two groups must also be different, right? Different, this part different. Okay, and of course chiral center. So let's take a look. The answer for this, if you look at it carefully, it would be option A. All right. So if I draw it out nicely, CH3, CH2, okay, CHBr, isn't it? So CH double bond CHBr, right? So you can see that this part would have cis trans, right? Because these two groups are different. This and this are different. H and this group are also different. All right. Okay, and the chiral center is actually over here. This is the chiral center. This carbon has 4 different groups. Okay, so the answer is A. Let's look at question 7. Which structural formula represents 2,2-dimethyl pentane? So pentane would be 5 carbon. 1, 2, 3, 4, 5. 2,2-dimethyl means you expect to have a this like carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So the methyl group is on the second carbon over here and over here. All right, and then all you need to do is to fill up all the rest with the hydrogen. Right, so CH3, CH2, CH2. All right, and this is of course CH3. Okay, so if you look at all the options, it looks like it's actually molecule option C. Okay, let's look at the next question. Okay, clavulanic acid is a beta-lactam drug that's used in combination with penicillin antibiotics to overcome antibiotic resistance. All right, how many stereoisomers are there? So stereoisomers, again, you're going to look out for CC double bonds, cis trans, as well as chiral center. So the chiral center, I would say, will be over here. 1, 2. All right, these two are chiral center, and over here the double bond. Okay, this double bond would have cis trans. So in fact, it will be 2 to the power 3, which is equals to 8. Right, so that's why the answer is D. Right, okay, so let's try the next question. Okay, let's look at how to do this question number 9. Compound V has a molecular formula C6H14O. It's an aliphatic carbon skeleton that is branched and contains a secondary alcohol. So how many constitutional isomers fit in this description? Okay, firstly, I'm going to draw all the possible branch aliphatic carbon skeleton. So I'm going to draw, say, 6 carbon, right? 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 5. Okay, but because it's branched, I'm going to put the last carbon over here. So the other possibility is you can draw also 5 and then you branch it over here. Okay, so I'm going to go to 4. So if you draw 4 carbon, 1, 2, 3, 4. Okay, you can do branching over here, 1 here and 1 here. You can also branch it like that, 1 over here and still 1 more over here. Okay. Okay, so these are the possibilities. So let's check how can you draw the secondary alcohol. So I'm going to put the secondary alcohol, the OH over here. Okay, we have to put it on those that is like that, because in this case, right, when you do this, then it'll be a secondary alcohol. Okay, so the other possible place that I can put the OH is actually over here. This will also be a secondary alcohol. Okay, for this molecule, the third molecule, I can put it over here. All right, or I can put it over here. But you know, if I put the OH over here, it's actually the same thing. So just put one over there. Okay, for this molecule, I cannot put any OH on any other carbon because it won't give you a secondary alcohol. For this one, I can put the OH over here. All right, so this becomes a secondary alcohol. Okay, so I've actually drew how many? 4 of them. So that's why the answer is C. Okay, let's look at the next question. Question 10. Okay, this diagram shows the structure of naturally occurring molecule cholesterol. Okay, so which statement about cholesterol is correct? It contains a secondary alcohol. Yep, this is a secondary alcohol over here. All right, that's right. Because this carbon has 2 R groups, 1 R group here and 2 R groups, so it's definitely a secondary alcohol. Okay, the molecule has 2 pi bonds. So where are the pi bonds? So there's a pi bond over here. Oh, there's actually only 1 pi bond. Okay, so this is definitely wrong. Let's look at the last one. All carbon atoms in the 4 rings lie in the same plane. Not possible because all these carbon are like tetrahedral. Okay, so this is definitely wrong. So the answer is D. Only one is correct. Okay, let's look at the next question. Okay, so they're asking that the structure of a renal contains an aldehyde group, a cyclohexene ring, and a long aliphatic side chain, where the carbon double bond exists on number carbon 11 and 12. All right. Okay, so I'm going to teach you a formula. This is what I call degree of unsaturation. It tells you how many double bonds and or rings in a structure. So having the formula is actually C plus 1 minus H plus halogen minus nitrogen. So there's actually 20 carbon. There's actually 28 hydrogen. There's no halogen. There's no nitrogen. So this gives you 21 minus, minus half here, minus half. All right, so minus 14. So this gives you 7. Okay, so firstly, they say it contains an aldehyde. Okay, so maybe I should tell you this first. If you get a value of 1, it means it could be a double bond or a ring. Okay, double bond could be C, double bond C, or C double bond O, C double, as long as a double bond. All right. Okay, so if you have 7, okay, firstly, they already have a C double bond O. Okay, that is actually an aldehyde. We have a cyclohexene, right? This is actually 2. Can you see that? So which means actually we have actually 3 over here. So since there's 7, right? It's 7. Because why is it 2 first? Maybe just some of you are wondering, why is it 2? Because there's a ring, it's considered 1, and double bond is 1, so it's 2. So here 3 means there's actually another 4 more CC double bonds, so to make up to 7. Right, so in the total number of CC double bonds will be 4 plus 1 here, so it's 5, right? So the answer will be either A or B. Can you see that? And since they tell you it's cis, so you need to have a cis structure. This structure is trans, and this structure is cis. So the answer has to be A. Okay, let's look at question 12. If a molecule contains 2 non-identical chiral carbon, 4 optical isomers exist. So this is the molecular formula, and this is a 5-membered ring. So maybe I just apply the formula again just to make sure it's correct. So C plus 1 minus half degree unsaturation, degree of unsaturation, H plus X minus N. So I have 7 carbon and I have 14 hydrogen. There's no halogen, there's no nitrogen. So it's 8 minus 7, that's 1. Okay, so there's actually probably just a ring. There's a 5-membered, there's no more double bond. So it's a 5-membered ring. I'm going to draw this. Okay, so I have actually 2 more carbon to draw, and you need to draw a tertiary alcohol. So maybe I'll draw this. This is a tertiary alcohol. And I can put 1 more carbon over here. Okay, all right, so that makes up formula of C7H14O. This is also tertiary alcohol, and I could put another carbon over here. I mean a carbon chain over here. All right, and the last one I could possibly draw. So you can see that Yeah, so how many isomers? You need to fit into all these formula, right? So the last one that I could possibly draw is actually still a tertiary alcohol, and this will be actually 2 carbon over here, right? So it fits into a 5-membered ring, tertiary alcohol, and this molecular formula. All right. Okay, yeah, so how many isomers are there? In fact, I'll say it over here. There are actually chiral center here, chiral center here. And for this molecule, there's no chiral center because actually this side is the same as this side. So this carbon is not chiral, okay, because these two groups are the same. All right. Okay, so very quickly, okay, so actually over here you can see that there are actually 4 isomers here. Why? Because it's 2 times 2. There are 4 isomers here, so 2 times 2, and there's actually 1 over here. So altogether, it's actually 9. All right, so 4 plus 4 plus 1, 4 plus 4 plus 1 will give you 9. All right, so that's how we look at it. Okay, let's look at question 13. All right, okay, the organic molecule has this composition, ability to rotate plane polarized light. So that means it has a chiral carbon, all right, probably a chiral carbon, and no cyclic structure. Okay, so I believe most of you will be able to get the empirical formula. Okay, you just divide by the, this is a percentage mass. So once you divide by the MR, which is like 12, divide by 1, divide by 16, you get these ratios. All right, and then you know it's 1 to 1. Okay, so if you started to think about what is the smallest number of carbon that can have this molecule, means this carbon has a chiral center, we'll do it bit by bit. So if this was a molecular formula, I can see that this is probably the structure. Okay, and it doesn't have any chiral carbon, so this is out. So if you move on to 2 times 2, so the times 2 means it'll be CH2O times 2, which means it's a C2H4O2. All right, and we try to draw it out, you realize that there will not be any chiral carbon. Okay, so let's look at it. These are the drawings, 1, 2, 3, 4. They all have 1 double bond. All right, and you can't get a chiral carbon from here. Okay, so which means the only possibility is to increase it by times 3. So CH2 times 3. So you try to draw C3H6O3. So if you try to draw C3H6O3, you can start to draw a chiral carbon. All right, so this is a structure. Okay, so which means, yeah, this is a chiral carbon, which means the smallest number of carbon must be 3. All right, question 14. Okay, how many possible stereoisomers exist for this compound? Okay, let's take a look. I'm just going to circle all the chiral center, and if there's any cis trans, I'll circle that too. So 1, 2, 3, 4, 5, 6, 7, 8. All right, and include this one. This one is also it has cis trans, so it's actually 2 to the power 9. So the answer is B. Okay, let's look at the next question. Question 15. How many constitutional isomers are possible for substituted benzene? So this is a benzene with another 2 more carbon. So if I try to draw a benzene, okay, with because benzene is 6 carbon, right? That's this C8. So it's probably going to look something like this. 1. You could also draw it like this. 1, 2. You could also draw it like this. 1, 2. And you also could draw it like this. 1, 2. Okay, anything else, it will be just a repeat. So the answer must be B. Thank you for watching the Twig Learning Center chemistry tutorial. I hope you learned something new. Don't forget to click the subscribe button so you'll be updated when new videos are posted.